Hi, I'm Norman Liss. The name of the program is The Way to Go. I invite you to join me each week at this time as we explore places to go and things to do. Format's a little different today. Instead of sitting across a table, we're sitting behind a table. And the reason is, as you may gather when you see the array of material that we have today, that we're talking science. The Hudson River Museum has a science initiative. And part of it is a man who's called the Science Buff, which rhymes with his name. He's Steve Ruff, and he is the science coordinator of the Hudson River Museum. And he's come here today to talk all about the museum and science and to show us a few things. Steve, welcome.
Thank you.
Before you do your first experiment, and we're going to start off the show with a bang, you promised me.
We sure are.
But before, how does one become a science buff?
Well, you can become a science buff by simply being interested in science. Science is just the search for knowledge through experimentation, just going out and trying something and seeing why it happens.
How early in your life did you know that you would be the science
buff? Well, I kind of started out with an interest in science in high school. I was part of the Environmental Science Club.
Right.
And I was just a club member then before becoming a buff. So, and not until I came to the museum and started doing an awful lot in science did I become the science buff.
But the Ruff became before the buff.
The Ruff came before the buff, yes.
Well, we said we'd start off with a bang. We've got a lot of things, a lot of demonstrations to show. So why don't we just start with this one? What are we going to do?
What we're going to do is do a little experiment with temperature and pressure. We're going to see what happens with a little bit of pressure in these cans.
You're cooking...
We're cooking some soda cans.
and is there water in them? Is that what it is?
That's right. There's water, and as you can probably see there's some steam coming out of those cans, so they're very hot.
Right.
And we're going to change their temperature very rapidly. And
we are going to do it?
You are going to experiment. This is, let's try it and see what happens.
Well, that's what you're doing at the museum, right? It's a participatory exhibit. People really get to do things.
Right.
Okay, I'm ready to go.
So we're in the experiment gallery.
My insurance is paid up.
Oh, good.
What do I do?
Okay, first of all, get your hands on some equipment here. With your other hand there, why don't we go ahead and hold this palm up.
Okay.
And gently grab the soda can there and invert it very quickly into that pan of water. And let's see what happens. Wow!
That really starts off with a bang.
It sure did.
What caused that to happen?
Well, what happened was you started out with a very hot
I haven't been
pan.
shot, have I?
I don't see any, no? Okay, everybody's all right. What we started out with was some steam coming out of the can. We heated up these cans with a little bit of water in them to create a very high pressure steam. And what happened was we put it into a pan of cold water.
Oh.
And that water is indeed very cold. So you change the temperature of the can very rapidly, causing the steam inside the can to condense very suddenly, creating a small vacuum inside the can, and also which was overwhelmed by the pressure outside the can, allowing it to just basically collapse on itself.
Is this typical of the sort of things that are being done at the museum?
Yes, this is one of the experiments you can do, and visitors are encouraged to participate in at the Science Diner, which is an area where people get their hands on science.
That's why the soda cans.
Right. We actually conduct this experiment with visitors, and along with the other ones we're going to do today, in addition to some electrical experiments, some experiments in sound and light, some experiments in chemistry. And then the stations also complement that, all the stations.
There are over 20 stations.
26 stations for hands-on science.
And so this is going on at all times, and whenever anybody comes to the museum, they can participate in these experiments? That's
exactly the whole point of this, is to get science out to the public in a way where they can do the experiments themselves.
The safety factor, of course.
Right.
I know you had a sign which we took away that said hot. Certainly have to keep away from things that are hot, but everything, I'm sure, is safe. This is for families as well as for kids. And you're involved with the school program at the museum, aren't you?
That's correct. I teach planetarium shows, also school programs related to environmental planetarium sciences, also physical sciences as well.
Is this in the museum?
That's right. It is inside the museum galleries, and you use the exhibits and also the workshop space.
And the school program, do you go into the schools with this too, or do the kids come in to the museum?
I also go out to some of our magnet schools, our special school partners that we have relationships with, and I go out and teach planetarium sciences in the classroom to our magnet schools and also environmental programs as well.
It's interesting to me that this museum actually started as an art and science museum, Yonkers Art and Science Museum, and now the emphasis is there's a whole science initiative going on here, which this, I suppose, is the forerunner.
It really is. It's a new initiative for a museum that traditionally has had science off and on, but now with the emphasis in science in curriculum, in school curriculum, and in society as well. We wanted to incorporate that into the science initiative, started in 1994, and culminating with this opening science exhibit, and with future exhibits to come. We have one on birds of prey next year, a wonderful environmental exhibit, and then the Hudson River Rama, which is a proposed exhibit which should be installed in a couple of years, which will emphasize the biology, ecology, and environment of the Hudson River.
Is that going to be inside as well as outside the museum?
We incorporate the outside, since we're right on the river there, into the permanent installation, which will be primarily inside, but with outdoor programs.
Sounds exciting. Why don't we do another experiment now?
Sure.
You're going to make me a science buff before this program's over, I assume.
You bet. Anybody can be a science buff if they just try a little.
Okay.
So we'll get your hands on some more science.
All right. I'm ready.
Are you ready? Your hands are ready. Okay, first of all, go ahead and...
Do as I do.
Do as I do, not as I say, right? Go ahead and grab a piece of paper and draw a circle about the size of a dime in the middle of that paper.
Is that before inflation or after?
That's about the size of the quarter right now. And go ahead and place that paper over the empty cup in front of you, that large plastic cup. And with your pencil there, go ahead and place the eraser end into the water, into the little baby food jar we have there. And what we're going to do is do a little experiment with color.
Okay.
And we're going to see a little change happen here. So let's go ahead and take that eraser out, place it in the middle of the circle that you just drew, and just let it daub the paper with the water. If there's not enough, go ahead and get some more, and we'll see what's happening here. As we say in the experiment gallery, let's try it and see what happens.
I think my quarter was too big for... Okay, it's getting long, and it's changing color.
It sure is. Look at mine. Mine's a little more of a penny size, but it's also changing color, too.
Where did the color come from?
Well, the color came from, not from the paper, and it didn't come from the water, so it must have come from someplace else.
The eraser?
Well, the eraser is just green. So where could it have come from? Perhaps it came from the marker. We started out with a black marker.
We sure did.
And yet we ended up with all these beautiful colors.
Yeah.
So what's happening here?
I like mine better than yours, to tell you the truth.
Well, what's happening, if you notice, how does yours change? You started out with the
colors.
Circle.
Yeah, and the colors seem to be moving outward.
Right.
And the black is changed to blue on mine.
Let's see if we can hold that up. Right, there's mine. I haven't added quite as much water as you have.
Let's show it over here. Right.
Oh, okay. And Norman, here is yours, and yours has actually expanded just a little bit further, indicating that you've added a little more water than myself, and you've also got more colors coming out.
Yes, I see that.
So you started out with black, but look at all the colors that came out of the black mark.
How is that possible?
Well, what we normally do with kids is invite them to try another one, and they'll compare it, and they'll actually come out with different patterns, indicating that there's a difference in the markers themselves. And that's actually what happens is you're looking at different manufacturers use different formulas for the black pigment in their markers.
So what you're saying is that the marker that we used actually had all these colors in it?
That's right. That's right. This is actually the most popular activity in the Science Diner, is just for young kids and adults. It's amazing to see their eyes wide open when they see the color changes. And when you compare the different manufacturers, you do get different patterns and different colors.
Well, I was involved at one time with the marker industry, and I have to tell you, I never heard this before. So, Steve, I'm so glad you came here. You certainly educated me, and our viewers certainly too, and I'm sure you're educating the people who come to the museum.
Well, we're trying to emphasize that each of these has a special name or a special experiment title. This is called chromatography. That really means color picture, and that's exactly what you're making. And chromatography is used in criminal investigations to find out about the autographs on a letter or piece of paper. They can use almost the same technique to separate out the colors and match ink and match different kinds of pens.
Where do these experiments come from? Are they something that you devise? Is it something that exists? I'm sure we're going to see more interesting, but I've never seen anything like this.
Well, it's kind of fun. It comes from the Science Museum in Minnesota, called the Experiment Gallery, and these activities were put together and designed by them. They're in St. Paul, Minnesota. And this exhibit has been traveling around the country for about 2 years now.
Really?
And we finally got a hold of it, and we're trying to get the ideas across that they designed.
Now, this exhibit has opened and will run through September, the middle of September. What kind of reaction have you had?
Boy, it's been a really positive reaction. People are saying, the Hudson River Museum has hands-on science, something we can get our hands into and get involved with.
The museum is, as far as I know, and I've been going to the museum for a long time, and I'm a member, and I'm a big supporter of the museum because I think that the museum does wonderful things. But there's usually been hands-on things that people can get involved with. But this is a departure as far as I'm concerned. I've never seen anything like this at the museum.
This is completely different from anything they've had before. They've never had a totally hands-on physical science experiment station set up like this. It's to let people know that we do have an interest in getting science out to the public.
Sure, it's great.
In a way we haven't quite been able to before.
Well, it certainly is a good way to do it, and I want to get on to some more experiments.
Sure.
But first I want to tell our viewers that what we're doing today is we're talking about the Hudson River Museum. My guest is Steve Ruff, who is the science buff, and we're just doing some science experiments, which is the sort of thing that you could do at the museum. All right, Steve, let's move on and do another one.
Okay,
are we going to set the place on fire? I see matches in front of me.
Well, hopefully we won't set the place on fire. We're going to start first by lighting those matches.
Okay.
Actually, if you want to get your hands on some more science, let's go ahead and light a match.
Okay. Why don't we just do this right up here where everybody can see it.
There we are.
All right. And then what are we going to do once we get it lit?
Here we go. I'll go ahead and light your match there, too.
There we go.
And we'll go ahead and light these votive candles.
All of them?
All of them. This is for a very dramatic experiment with a little bit of cold.
I'm not very good at this.
Something very, very cold we're going to try next.
Will you see that?
It's called a little bit of fire and ice.
Well, I think I'm going to let you do it because I don't seem to be lighting them too well.
Well, these votive candles have been these are the...
They get my vote.
Yes. Let's see if we can get that other one there.
Okay. Now, what are we going to do with them?
Okay, we'll go ahead and extinguish that in this. We call that the sand can. It's just a nice little place to extinguish our...
What are we going to do before we set the studio on fire?
Well, what we're going to do is go ahead and I'd like you to take this picture right here.
Okay.
And draw it as you would water. Just dip right down into the bottom of that box. And we're going to actually try a little something. Don't collect the ice particles themselves, but go ahead and collect some of the invisible stuff that's in there.
I didn't see anything there.
Well, believe it or not, there is something in there.
I got to...
Now let's see if we can pour some out.
Into the...
Right over that first candle there, and we'll see what happens.
Yeah,
what happened there?
What was
Try
that?
the other one. See if there's anything left.
Not quite. I've got to get some more.
Let's try some more. Some of that magic invisible stuff in there. We're going to try and find out what that is. Wow.
That is amazing.
How about that?
I could use that in my magic act.
Well, science is magic, a little bit.
It certainly is. What happened?
Well, what happened was, what we did was use that pitcher to dip into where that dry ice is. That's actually what's inside that tray over there. You can take a look at those frozen chunks of carbon dioxide, that's solid CO2. It's the same stuff we breathe out every day, but it's in a very concentrated form. And it is, at this temperature that we're sitting at now, it exists in two forms, as the solid that you see, and as a gas, as a very concentrated, invisible gas. And it sits down in the bottom of that tray because it's so concentrated, it's heavier than the air around it.
I did feel it when I picked it up. It was,
It was
quite
a little
heavy.
heavier than the air. And even though you couldn't see it, it was there. And that's how we could prove it, was to actually extinguish the flames.
It's amazing.
By using carbon dioxide.
Never would have thunk it.
Now, how about that? Well, there's something else we can do with that carbon dioxide gas.
Okay, shall we do it?
Sure.
You have to move over there?
Okay. Okay, here we go. Am I?
Okay.
There we are. Okay, what I'd like to try first is to actually, this is going to be interesting. Actually, if you'd like, why don't you go ahead and get your hands on science once again. I'm making you do a lot of work here, but this way you'll see what it's like by
what do I do?
Experiencing it. Go ahead and dip down into the box. Pick up a piece of that dry ice there.
Not the invisible one?
Not the invisible stuff. What is that noise? Keep holding on to it.
I've got it.
Let's go ahead and bring it up. Did you notice that the noise stopped?
Yeah.
That means something was happening here. When you picked them up with the tongs, which are at room temperature, against the dry ice, which is cold, then something sizzled. That's exactly right. And you notice the edge of the tongs are beginning to frost over there.
Yes.
Well, what's happening is the tongs are basically at the same temperature as the dry ice when the noise stops. So what we can do with this, actually, is we'll go ahead and try a little something else with that. You can go ahead and take that out. We have another interesting experiment called Shivering George, and we have a little George here in the form of a quarter.
Right in the center here?
Yeah, that's fine. You can go ahead and hold on to the tongs right there.
I got it.
And let's see, we're going to go ahead and place this warm quarter inside the dry ice by simply putting that warm quarter against the surface. And we'll see what happens there. Let's warm it up a little bit. So here we go. Let's go ahead and warm up that quarter a little bit. It has to be a little bit warm. Just like your tongs were making noise, we're going to watch this quarter do something very interesting.
Change into a $100 bill?
I wish it would. I could use it. Let's see.
Same noise.
Okay, it's making the noise. Okay, George should be... Let's try it again. There we go. Go ahead and raise that up to the camera there.
It's shaking.
There's Shivering George at Valley Forge.
Huh.
He was very cold in that gorge.
No.
And you can see that happening with the quarter there.
What caused that?
Now, very soon, the quarter will also reach the same temperature as the dry ice, and it'll stop shivering. So what's happening is, all the time, you can see this gas, well, you can see some of the gas coming off of the carbon dioxide. The frozen carbon dioxide is giving off its gas form all the time, all the time.
Is that freezing over,
and
too?
What's happening is, yes, this is also freezing the water vapor in the air, just like the tongs here, building up a little coating of ice. And when it stops shivering, that means the quarter has reached the same temperature as the dry ice. So it doesn't feel that pressure of gas coming off anymore. It's the same temperature as the block of ice here, which is about 190 degrees below zero.
Now, you certainly can't touch dry ice.
No, it's too cold. It'll definitely burn your finger.
So how do we get
How do we handle this? How do we get the quarter out? Oh, we have a pair of gloves right down here.
Okay.
And should I?
Yeah, go ahead.
Okay, what we'll do is gently take the quarter out, handling it with the gloves because it is at 190 degrees below zero. Take it out, and it'll very quickly warm up to room temperature. And you can place the tongs back with the dry ice back in the box here. Just release. The tongs have frozen to the dry ice. Here we go. There we are. And you can leave those out, and those will also warm up. And actually, what we're going to do is try something, another interesting
Why don't you get back over on that side?
experiment here. Okay, go ahead and take this over there.
Well, one of the things science hasn't done is found a way to have a microphone on that it will stay on where it belongs. But we'll put it back on where it belongs.
Okay.
And we'll be back in business. Okay, Steve, more science.
More science. Let's go.
What do we do now?
Let's see.
Are we
going to
do something with this?
Yeah, actually, why don't we try that? Okay. We'll save the last little surprise for later.
Okay.
Go ahead and...
should we bring that out in the front where it can be seen?
What we have here is a rack with some bubble solution in it. This is a simple bubble solution that you'd find
Always
in
wanted
the
to play
store.
with that.
Toys R Us and all the other toy stores carry bubble solutions with bubble wands. Go ahead and take out a wand there and blow some bubbles into the box.
Into
the box with the dry ice in it. Let's try that, yeah.
I haven't done this for years.
It's just a gentle blow. It takes a... There we go. What do you see happening inside the box there?
They're not sinking.
That's right. So what's going on? There's some science going on in that box. It's also, looks like magic, but it's really a little bit of carbon dioxide science. What's happening is those bubbles are floating on that carbon dioxide gas.
That same invisible gas
that
we use to put out.
That's exactly right. And what happens is that carbon dioxide gas, being heavier than air, falls to the bottom of the box, and it's constantly being given off by those blocks of dry ice in there. And what's happening is you build up more and more carbon dioxide gas.
And that keeps going all the time.
It keeps going all the time, and it's too heavy for the bubbles to penetrate because the bubbles are filled with your air that you blew in. But soon enough, you'll see something happen here. There are a couple of things that happen to bubbles when you put them inside there with the carbon dioxide. First, they will float, as you see.
Yes.
That bubble is perfectly floating. That's a very nice job you did there.
I'm very good at it.
Yes.
I'm not so good with microphones, but I'm pretty good with
Blowing
bubbles.
bubbles? Well, as we'll notice, something will change about that bubble. It'll start to, in a few moments, we'll go over to this other one and we'll watch that. Well, that actually didn't last long enough.
Nope.
Go ahead and let's try some other bubbles in there.
Yes, boss. Can we stay after school? There we go.
There we go. Boy, they're really dancing around, aren't they? Well, some of those bubbles, if they last long enough, they'll start to change color. As you can see they're all multicolored now.
Yes.
Well, over time, that soap film will start to fall towards the bottom of the bubble, getting a little bit thinner on the top, a little bit thicker on the bottom, because we have gravity influencing those bubbles all the time, which will draw that color out of the bubble and make it clear. I see we have a couple of small clear bubbles there, a couple of colorful ones there.
Yes.
And look at this one, getting bigger.
Yes.
Getting also lower in the bottom. There's something happening with that bubble, too. It's also starting to become clear. Well, this bubble right here is actually getting larger and becoming clear because it's starting to absorb the carbon dioxide through its membrane, through its wall. And what happens is it actually absorbs that gas, that carbon dioxide gas, gets a little heavier, and eventually pops when it gets too cold and too thin at the top.
I feel as if I just failed when that bubble broke. My bubble has burst.
Yeah, you're right. I think, sorry I burst your bubble there.
These few experiments that we're doing here, they're really terrific. And you said 26 different places that things are taking place?
Sure do. We have, in addition to these Science Diner experiments, which are also more numerous than what we have right out here, there are those 26 hands-on stations in electricity, light, sound, mechanics, and the weather. You can change the orbit of the Earth, for example, and see what happens to the seasons on a computerized model.
Kids of all ages?
Kids of all ages. They can even make snow with their own breath over there, too. And in the electricity area, you can build your own circuit, light your own fan, or make your own light, run your own fan, build a motor at the Science Diner.
Before we run out of time, I want to make sure that we give the telephone number that people can call to get more information about this exhibit and all the other exhibits that are going on. We're devoting our time to this one exhibit today, but in a few weeks, Philip Very, who, of course, you know, is the director of the museum, will be coming on the program and talk about overall plans and what's going on. So I just want to stay with science today, but the telephone number for people to call to get more information, to get on the mailing list.
If they want to get on the mailing list, become a new member, the phone number is 963-4550. And Suzanne Smith is our membership director there. She'll be happy to.
And we put that up in the closing credits so that people can get that. Let's go to
one last thing. This is sort of our climactic piece here. What we're going to do is blow up balloons with some of that CO2. I know we breathe into balloons to blow them up, but let's try something
Versatile
different.
CO2.
I'll tell you.
Here are the balloons.
Well, what we could do is actually use the gloves here And I'd like you to go ahead and try it this time.
All
Reach
right.
in and get a small piece of dry ice. Get a couple of small pieces and put it inside that little bottle there.
Okay.
This is getting your hands on science.
It sure is.
Some of them might have frozen to the bottom of the...
Question is, how do I get it in?
Okay.
I haven't figured out how to do that yet.
Let's try maybe that one.
There's one that we're
There
going
we go.
there.
That should fit in there. Boy, it's shivering too.
Yes, it is. I can hear it.
It's that temperature difference affecting
There we
us
go.
again.
Is that enough?
That should be enough. And go ahead and let's see if we can stretch a balloon over the top of
Why
one of
don't you
these.
do that?
Okay.
I don't want my
Let's see, what we'll
fingerprints
do
on it,
is-
so I'm wearing the glove.
Oh, so we don't know who did it.
That's right.
Okay, here we go. Let's see what happens when we place the balloon over the top of the jar there, over the top of the bottle. And we'll see what happens. There's something happening right away. Wow. What's going on inside there?
This is all this carbon dioxide, the great properties of carbon dioxide, which you're
It
demonstrating
really is
today.
amazing.
So those gases are rising and filling the balloon?
What happens is, remember the bubbles floated on that cushion of carbon dioxide in the box over there. Well, we're creating another cushion of carbon dioxide, but there was already air in the bottle. So that carbon dioxide is displacing some of that air, forcing it somewhere, forcing it up, until it finally, that air that was in there is entering the balloon. So there will be more and more carbon dioxide gas coming off of the dry ice, pushing that air further up into the bottle, and then eventually up into the balloon. And we're going to watch our balloon get a little larger over time.
Well, we
there.
won't be able to watch it too long because we've run out of time. And I thank you so much, Steve, for coming here and showing
You're
us
quite
these
welcome.
experiments and talking about the Hudson River Museum. What we've been doing today is talking about this great exhibit at the Hudson River Museum. It'll be there through the middle of September. This is only a sampling. It's just great. Go there and enjoy it. And I'm Norman Liss, and the name of the program is The Way to Go. And until next week at this time, enjoy yourself.